There are 2 trillion galaxies in the observable universe. Each one contains billions of stars. Billions of planets orbit those stars. The numbers sound overwhelming, like the cosmos should be crowded, buzzing, alive with light and matter in every direction. But here is the truth that breaks your intuition completely. If you shrank every star in the Milky Way to the size of a grain of sand and spread them out at their correct relative distances, each grain would sit alone in a desert stretching miles in every direction, with nothing in between. The universe is not full. It is almost entirely nothing. And the emptiness is not some background detail. It is the single most dominant feature of everything that exists. What you are about to hear will change how you see the night sky forever. If you enjoy journeys that completely reshape how you see reality, go ahead and hit that like button and subscribe. It genuinely helps this channel keep exploring the strangest truths in the cosmos. Now, get yourself comfortable. Let's begin. Go outside tonight. Find a dark place, away from the streetlights and the glow of the city, somewhere the sky opens up fully above you. Wait for your eyes to adjust. Let the pupils widen. Let the darkness settle in. And then look up. What you will see is a sky that appears to be filled with stars. Thousands of them. Some bright, some faint, some flickering through the churning layers of atmosphere above your head. They seem scattered so thickly in certain parts of the sky that they blur together into a pale, luminous river. That river is the Milky Way, seen edge on from inside, and it looks like the cosmos is overflowing with light. You feel surrounded, immersed in a universe that glitters from every angle, dense with suns and worlds and possibility. This experience is one of the oldest in human history. Every civilization that has ever existed has looked up at the same spectacle and drawn the same instinctive conclusion. The universe is full. Space is populated. The sky is rich with suns. From the first nomadic tribes navigating by starlight to the Polynesian wayfinders who crossed oceans guided by stellar patterns to the modern child lying on a blanket in a suburban backyard, the message has always been the same. The cosmos is a crowded, glittering place, packed from horizon to horizon with worlds beyond counting. The sheer visual weight of the night sky is one of the most powerful impressions a human being can receive. It feels like evidence. It feels like proof. And this feeling only intensifies when you bring in modern science. The naked eye can see roughly 5,000 stars on a clear night from a dark location. Binoculars reveal tens of thousands more. A modest backyard telescope opens the sky to hundreds of thousands, and the most powerful observatories we have ever built, instruments like the Hubble Space Telescope and the James Webb Space Telescope, have revealed that our galaxy alone contains somewhere between 200 billion and 400 billion individual stars. Each one is a nuclear furnace burning millions of tons of hydrogen fuel every second. Each one is potentially orbited by planets. Each one radiates its own sphere of light and gravity and energy into the surrounding space. Beyond our galaxy, the numbers grow even more staggering. The observable universe contains an estimated 2 trillion galaxies. 2 trillion separate collections of stars, gas, dust, and dark matter, each one containing its own billions or hundreds of billions of suns. Some estimates suggest the true count could be even higher, perhaps 6 trillion or 20 trillion, once you account for all the dwarf galaxies too faint for current telescopes to detect. The total stellar population of the observable universe reaches somewhere around 1 septillion. That is a 1 followed by 24 zeros. More stars than grains of sand on every beach on Earth. More suns than seconds that have elapsed since the Big Bang. With numbers like these, the universe should feel packed, overflowing, crowded in every direction with matter and energy and light. You should not be able to point a telescope anywhere without hitting something. And in a sense, that is exactly what happens. The Hubble Ultra Deep Field proved it. Scientists aimed the telescope at a tiny patch of sky that appeared completely empty to the naked eye. a region no larger than a grain of sand held at arm's length against the darkness. They kept the shutter open for 11 days, collecting every photon that drifted in from that minuscule window. When they processed the image, that seemingly empty speck of darkness contained over 10,000 galaxies. Not stars, galaxies. Entire island universes, each one home to billions of suns, crammed into a space on the sky that your thumb could cover at arm's length. Every apparently blank region of sky is actually filled with galaxies too faint and too distant for human eyes to detect. Everywhere we look, there is something. The cosmos is populated at every scale, at every distance, in every direction. The sheer abundance seems irrefutable. So, the universe is full, right? No. And this is where human intuition fails so completely that most people never recover from the correction. Because the universe is not full. It is not crowded. It is not dense or packed or busy in any physically meaningful sense. It is, by any honest measure, almost entirely empty. And the emptiness is so overwhelming, so dominant, so absolute in its scale, that it makes every star, every galaxy, every planet you have ever heard about seem like a rounding error in a cosmos made almost entirely of nothing. The mistake your brain makes is a simple one, and it is the same mistake every human brain has made since the first person looked up at the stars and tried to understand what they were seeing. You confuse the number of objects with the distribution of objects. These are not the same thing. They are not even close to the same thing. And understanding the difference between them is the key to understanding why the most populated universe imaginable can still feel devastatingly, overwhelmingly empty. We do this constantly in everyday life without realizing it. When you say a forest is full of trees, you mean the trees are close enough together that you cannot walk a straight line without encountering one. The number of trees matters, but what really makes the forest feel full is the density, the proximity. If you took those same trees, every single one, and spread them out across the Sahara Desert at equal intervals, you would no longer have a forest. You would have a wasteland containing occasional trees. The count is the same, but the experience has transformed completely because the distribution has changed. This is what the universe does with its stars, and it does it at a scale that makes the Sahara comparison look laughably small. Think about it another way. There are approximately 8 billion people on Earth. That is a staggering number. It feels crowded. Cities overflow. Highways clog. Subway trains pack so tightly you cannot lift your arms. But Earth has a surface area of roughly 197 million square miles. If you distributed those 8 billion people evenly across the entire planet, including every ocean, every desert, every ice sheet, every mountain range, and every stretch of empty tundra, each person would stand alone with almost 60 acres of empty ground around them in every direction. No neighbours in sight, no buildings, no roads, no evidence that any other human existed at all. Just open, silent emptiness stretching to the horizon. You could walk for hours, for days, and never encounter another living soul. 8 billion people. And yet, spread across the actual surface of the planet, they vanish. The population is enormous, but the space is more enormous still. The number of objects is staggering, but the volume containing those objects is staggeringer. And when the volume wins, it does not matter how many objects you have. They disappear, they thin out, they become lonely, isolated specks in an ocean of emptiness. Now take this principle and apply it to a cosmos that is not hundreds of millions of square miles, but billions upon billions of trillions of cubic light years. Take the most incomprehensibly large number of stars you can imagine, the most absurd census of galaxies that modern astronomy has ever produced, and drop them into a volume of space so vast that the human brain has no biological mechanism for processing it. What happens? They disappear. They dissolve into the emptiness like a handful of salt thrown into the Pacific Ocean. The stars are real. The galaxies are real. The numbers are staggering beyond language, but the distances between them are more staggering still. And it is the distances, not the objects, that define what space actually is. Start close to home. Our sun is one star among those hundreds of billions in the Milky Way. It seems embedded in a rich galactic environment, surrounded by stellar neighbours, part of a vast community of suns. The nearest star to our solar system is Proxima Centauri, part of the Alpha Centauri triple star system, and it lies approximately 4.25 light years away. 4.25 light years. That translates to roughly 25 trillion miles of empty space between our sun and its closest stellar neighbour. 25 trillion miles of near vacuum separating two objects that, by cosmic standards, are right next to each other. 25 trillion miles is not a number your brain can process. No human brain can. So let me make it physical. If you shrank the sun down to the size of a ping pong ball, roughly 1.5 inches across, and placed it on a table in front of you, where would you need to place the next ping pong ball to represent Proxima Centauri at the correct relative scale? Not across the room, not across the street, not across your town. You would need to place it more than 600 miles away. Picture that. Two tiny white spheres, one on a table in front of you, the other in a different state or a different country, depending on where you started. And between those two spheres, nothing. No other balls, no other objects, no structure of any kind. 600 miles of pure, uninterrupted emptiness separating two neighbours that the galaxy considers close. And this is not some exceptional gap. This is not some unusually desolate region of the Milky Way. This is typical. The average distance between neighbouring stars in our galaxy is approximately 5 light years, roughly 30 trillion miles. According to the National Radio Astronomy Observatory, that figure holds generally across much of the Milky Way, though there is significant variation depending on where you look. In the outer spiral arms where our solar system resides, the typical separation is wide and lonely. Near the galactic centre, stars cluster more tightly, but everywhere, at every location, the same fundamental truth holds. Stars are tiny points of matter separated by incomprehensible oceans of vacuum. Now consider what fills that gap. The answer, for all physical purposes, is nothing. The space between stars is called the interstellar medium, and while it is not a perfect vacuum, it is so close to one that it obliterates every human analogy for emptiness. Interstellar space in our neighbourhood contains, on average, approximately 1 atom per cubic centimetre, one single hydrogen atom floating alone in a volume roughly the size of a sugar cube, one solitary particle, invisible, silent, unattached to any other particle, drifting through a vacancy that stretches for trillions of miles in every direction. To put this in perspective, ordinary air at sea level is more than 10 billion times denser than the typical space between stars. The best vacuum chambers ever constructed in laboratories on Earth, facilities designed specifically to remove as much matter as possible from a sealed container, still contain tens of thousands of molecules per cubic centimetre. NASA has confirmed that even these engineering marvels, the most perfect emptiness human technology can achieve, are still tens of thousands of times denser than the interstellar medium. The space between stars is not just empty. It is empty in a way that exceeds every vacuum humans have ever manufactured by 4 orders of magnitude. It is emptier than our technology knows how to create. If you could take a cube of interstellar space the size of the Earth, roughly 8,000 miles on a side, and somehow compress it, squeeze out every atom and every particle from the entire volume, you would barely have enough material to fill a modest room. The space between stars is not merely sparse. It is a void so extreme that it is closer to philosophical nothingness than to anything humans experience as empty. Interstellar space is empty by the standards of physics itself. It sits below every threshold of emptiness that humans have ever defined, in any context, for any purpose, and it is not even close to the emptiest thing in the universe. And yet, remarkably, this staggering scale of emptiness does not even represent the most extreme vacancy in our cosmic neighbourhood, because the space between stars, sparse as it is, exists within a galaxy. Stars are the exceptions, but at least they exist. They dot the darkness at intervals of a few light years. The interstellar medium, for all its sparseness, still contains a scattering of atoms, a faint wash of radiation, occasional wisps of dust. There is something there, even if the something is almost nothing. But when you zoom out from the galaxy itself, even these faint traces of substance begin to disappear. Consider our own solar system first. This is the densest, most matter-rich environment most humans will ever think about in daily life. We have the Sun at the center, containing 99.86% of the solar system's entire mass. We have 8 planets orbiting it at various distances. We have over 200 known moons circling those planets. Millions of asteroids populate the belt between Mars and Jupiter. Billions of icy bodies drift through the Kuiper belt beyond Neptune. And the distant Oort cloud, a hypothetical sphere of comets surrounding the solar system at extreme distance, may contain trillions of frozen objects. It sounds busy. It sounds full. It sounds like a rich, well-populated region of space. It is not. If you gathered every planet, every moon, every asteroid, every comet, every ring particle, and every grain of dust in the entire solar system, excluding the Sun itself, and compressed all of it into a single object, that object would fit inside a sphere roughly the size of Jupiter. One planet, one object, about 86,000 miles across. Now consider the volume of space that the solar system actually occupies. The heliosphere, the bubble of solar wind that marks our star's sphere of influence, extends roughly 100 astronomical units from the Sun. 1 astronomical unit is the distance from the Earth to the Sun, about 93 million miles. The total volume of the solar system is enormous, and the material inside it, all those planets and moons and asteroids, fills less than 1/trillionth of 1% of that volume. Less than 1/trillionth of 1%. The solar system is not a crowded neighborhood of orbiting worlds. It is a vast, howling emptiness that happens to contain a few tiny specks of rock and gas circling a single, ordinary star. If you could somehow see the entire solar system from the outside, rendered at a scale where the orbits were visible, the planets themselves would be invisible. Not small, invisible. Dots far too tiny to register against the blackness. You would see the Sun reduced to a modest point of light and nothing else. If you flew a spaceship from Earth directly toward Proxima Centauri at the speed of the fastest spacecraft humanity has ever launched, the Parker Solar Probe at its peak velocity of roughly 430,000 miles per hour, the journey would require approximately 6,500 years. You would depart Earth at a time when the first pharaohs were raising monuments in the Egyptian desert. You would pass through centuries of human civilization without arriving. Empires would rise and fall back on the planet you left behind. Languages would be born and die. Entire species would evolve and go extinct. And you would still be travelling, surrounded by nothing, drifting through interstellar space with no landmark, no waypoint, no visible evidence that you were making progress at all. The stars outside your window would barely shift. The darkness would remain total. You would simply drift through an emptiness so vast and so featureless that the human mind would struggle to distinguish one millennium of the journey from the next. This is what the space between stars actually is. Not a gap, not a corridor, not a distance that technology could someday conquer in a reasonable time frame. It is a void so immense that crossing it at speeds our species has never achieved would still require longer than all of recorded civilization. Even light itself, the fastest thing in the universe, the absolute speed limit of physical reality, needs more than 4 years to make this crossing. A beam of light that left Proxima Centauri the year you were born has been racing toward us at 670 million miles per hour every second of your life. And depending on your age, it may not have arrived yet. Light, which can circle the Earth 7 times in a single second, requires years to cross the gap between 2 neighbouring stars. That is not a measurement of distance, that is a measurement of loneliness. And here is where the true shock begins to take shape. Because everything described so far, every staggering number, every impossible distance, every mind-breaking comparison, all of it refers to conditions inside our galaxy, inside one single galaxy out of trillions. This is the environment within one of the denser, more structured, more matter-rich regions in the entire observable universe. Inside the Milky Way, we are surrounded by hundreds of billions of stars. We are embedded in spiral arms of glowing gas and dust. We have stellar neighbours within a few light years. We have nebulae and star clusters and molecular clouds within a few hundred light years. We have structure, we have company. This is, by cosmic standards, a crowded, bustling, well-populated place. One of the more interesting addresses in the universe. And it is almost entirely empty. When you leave the galaxy, when you cross from the Milky Way's outermost halo of ancient stars and scattered globular clusters into the true intergalactic void, the emptiness does not merely continue at the same scale. It intensifies by orders of magnitude. The space between galaxies makes the space between stars look positively dense. If the interstellar medium contains roughly 1 million atoms per cubic meter, the intergalactic medium drops to approximately 1 atom per cubic meter. According to the Harvard-Smithsonian Center for Astrophysics, that single atom floats alone in a space the size of a large refrigerator, with the nearest neighbouring atom an equivalent distance away. That density is less than a billionth of the density of air at sea level on Earth. It is, for all practical purposes, a perfect vacuum, the closest thing to true nothingness that the physical universe permits. The nearest major galaxy to our own, Andromeda, lies 2.5 million light-years away. Between us and Andromeda stretches a gulf that contains, in any practical physical sense, nothing you could see or touch or meaningfully detect. A few stray atoms of hydrogen, a faint wash of plasma so sparse and so hot that it carries almost no energy per unit of volume. Some scattered dark matter, invisible and silent, and detectable only through its gravitational effects on distant light. That is all. 2.5 million light-years of effective nothingness, and Andromeda is our neighbour. It is the nearest large galaxy to the Milky Way. It is so close, by cosmic standards, that we can see it with the naked eye on autumn evenings as a faint smudge of light in the constellation that bears its name. The distances to other galaxies climb from there with sickening speed. The Virgo cluster, the nearest major galaxy cluster, lies roughly 54 million light-years away. The Coma cluster sits over 300 million light-years distant. The most remote galaxies we have detected sit more than 13 billion light-years from Earth, their light having travelled for nearly the entire age of the universe to reach us. Between us and those distant objects stretches space that is emptier than anything humans have ever experienced in any context. Emptier than anything our biology was built to imagine, emptier than the word empty can meaningfully convey. This is the reality that the night sky hides from you. When you look up and see thousands of stars and feel that the universe is full, you are experiencing an optical illusion, a selection effect created by the fact that human eyes detect light, not darkness. You see the bright exceptions, you cannot see the overwhelming rule. And the rule is emptiness. The rule is vacuum. The rule is separation on a scale so immense that the objects themselves become cosmically irrelevant compared to the spaces between them. Every star you see is a tiny island. Every galaxy is a tiny archipelago. And the ocean between those islands is not merely large. It is so overwhelmingly, incomprehensibly, structurally vast that the islands, all of them, every star and planet and galaxy in the observable universe combined, would fill less than 1/1000% of the total volume of space. The rest, the overwhelming, annihilating rest, is vacuum, darkness, distance without destination, emptiness without boundary or end. And here is the thought that should stop you where you stand. If even the densest region humans have ever known, a star surrounded by its own planets, embedded in a galaxy containing hundreds of billions of other stars, located in a universe containing trillions of galaxies, is overwhelmingly empty at every single scale of analysis, then what does that say about the universe itself? It says something that most people have never been told clearly, something that overturns the instinct you feel every time you look up at a clear night sky. Emptiness is not the background of the cosmos. It is not the gap between the interesting parts. It is not the negative space that separates the things that matter. Emptiness is the dominant physical reality at every scale, from the spaces between planets to the spaces between galaxy superclusters. The universe is not a collection of objects with space between them. It is a collection of separations that happen to contain a few scattered, tiny, fragile points of matter, and the separations are winning by a margin so vast that the objects barely register. But the story does not stop here, because so far we have only examined emptiness at the level of individual objects, the gaps between neighbouring stars and neighbouring galaxies. We have measured the distance between islands without considering the ocean itself. The true structure of cosmic emptiness is far stranger and far more absolute than anything we have covered yet. The universe is not just sprinkled with lonely objects in empty space. It is organised into a vast architecture, a grand scaffolding of matter and void that spans billions of light years in every direction, and whose single most dominant structural feature is not the glittering filaments of galaxies that astronomers love to photograph. It is the emptiness itself, the enormous bubbles of near nothingness that occupy the overwhelming majority of cosmic volume, stretching hundreds of millions of light years across, containing almost no matter of any kind. These are not gaps. They are the defining features of the cosmos. They are the architecture, and they dwarf everything else in the universe. And those voids are not stable. They are not static. They are not simply sitting there as passive gaps between more interesting things. They are growing. They are accelerating their growth, and they are slowly, silently, irreversibly consuming everything else in the cosmos. The emptiness between individual stars is staggering. The emptiness between individual galaxies is worse. But both of these are local measurements. They describe the gaps between neighbouring objects, the distances separating one island of matter from the next closest island. They do not describe the overall layout of the cosmos. They do not answer the deeper question: how is all of this emptiness organised? Because it is organised, that is the part that changes everything. For most of human history, astronomers assumed that galaxies were scattered through the universe more or less randomly. Some regions might be slightly denser, some slightly sparser, but on the whole, the distribution was expected to be roughly uniform. Galaxies were like raindrops in a storm, falling everywhere with no particular pattern, filling space in a way that looked uniform when you stepped back far enough. This seemed reasonable. It matched the cosmological principle, the foundational assumption that the universe looks roughly the same in every direction and from every location when viewed at sufficiently large scales. A random scattering of galaxies would fit that principle neatly. Then, in the late 1970s and early 1980s, astronomers began doing something that had never been done before. They started measuring not just the positions of galaxies on the sky, but their distances. Using redshift, the stretching of light caused by cosmic expansion, scientists could calculate how far away each galaxy was. For the first time, they could build three-dimensional maps of the universe, not flat photographs, not two-dimensional projections, actual depth maps showing where galaxies sat in three-dimensional space. What they found overturned everything. Galaxies were not scattered randomly. They were not distributed like raindrops in a storm. They were not sprinkled across the cosmos in the smooth, featureless way that the cosmological principle seemed to suggest. Instead, they were arranged in an intricate, interconnected pattern that no one had predicted and no one fully understood. The first maps were crude, containing only a few thousand galaxies, but the pattern was unmistakable. Galaxies clustered along long, thin filaments stretching hundreds of millions of light years across the cosmos. Those filaments connected at dense nodes where galaxy clusters formed. Sheets and walls of galaxies extended across even larger distances. And between all of these features, filling the enormous spaces where the threads and walls did not reach, were regions of almost nothing. Spheres and irregular shapes of space, tens of millions to hundreds of millions of light years across, containing almost no galaxies at all. The maps looked organic, like cross-sections of bone marrow or neural tissue. They did not look like anything cosmologists had predicted. Scientists called this pattern the cosmic web, and the empty regions within it, the vast bubbles of near-nothingness that the filaments surrounded but did not penetrate, were called cosmic voids. The cosmic web is the largest structure in nature. It spans the entire observable universe, and every galaxy that has ever been observed, every star, every planet, every atom of ordinary matter that exists in any form, occupies some position within it. Nothing lies outside the web. The web is everything. And the single most important thing about it, the thing that matters more than any other feature, is this. Most of the web is empty. Imagine a bathtub filled with soap foam. Look at the foam closely. You see a complex lattice of thin bubble walls, intersecting at edges and vertices. The walls are where the soap film gathers. They are thin, fragile, and they contain almost all of the soap. But the bubbles they surround, the hollow spheres of air inside the foam, are where the volume is. If you measured the total volume of the foam, the overwhelming majority of it would be air, not soap. The soap clings to the surfaces of bubbles. The air fills the interiors. The structure looks intricate and busy, but it is made almost entirely of empty space with a thin tracery of material draped around the edges. The cosmic web works the same way. Galaxies are the soap, voids are the air. The filaments and walls where galaxies cluster are impossibly thin compared to the volumes they enclose. Thin membranes of light and matter stretched across the surfaces of enormous empty cavities. The voids they surround are staggeringly, overwhelmingly, structurally dominant. They are not the spaces between the interesting parts of the universe. They are the universe. The filaments are the decoration. The voids are the substance. The universe is foam, and almost all of the foam is bubble. How dominant are the voids? Observational surveys conducted over the past several decades have provided increasingly precise answers to this question. The Sloan Digital Sky Survey, which began operations in the year 2000 and eventually mapped more than 1 million galaxies in 3 dimensions, revealed the cosmic web in unprecedented detail. The Baryon Oscillation Spectroscopic Survey extended this work even further. The resulting maps, some of the most stunning visualizations in all of science, show filaments of galaxies winding through space like luminous rivers, connecting at bright intersections where clusters sit, and between those filaments, dominating every map, are the voids. Dark, enormous, empty. The maps reveal that cosmic voids occupy approximately 80% of the total volume of the observable universe. 80%. 4/5 of everything that exists, measured by the space it takes up, is void. Not filament, not cluster, not galaxy. Void. And within those voids, the density of matter drops to roughly 20% of the cosmic average, sometimes lower. In the deepest cores of the largest voids, the density can plunge to 10% of the mean or less, 1/10 of the already vanishingly low average density of the universe. These regions are empty in a way that makes the space between stars look congested. Let that sit for a moment. 80% of the universe, by volume, is void. The galaxies, the filaments, the clusters, the superclusters, everything that glows and burns and orbits and collides, all of it is confined to the remaining 20%. The cosmic web, that looks so intricate and grand in survey maps, is a minority structure, a thin lacing of matter stretched around enormous hollows. The universe is not a warehouse full of objects. It is a warehouse that is almost entirely empty, with a few cobwebs clinging to the corners and edges. To grasp how extreme these voids truly are, consider one specific example that haunts astronomers to this day. The Botez Void, discovered in 1981 during one of the first large-scale redshift surveys, is a roughly spherical region of space, approximately 330 million light-years in diameter. 330 million light-years. That distance is so large that light leaving one side of this void at the moment the first dinosaurs walked on Earth would still not have reached the other side today. The void is wide enough to swallow the Milky Way, Andromeda, the entire local group, the Virgo cluster, and everything in between. and still have room left over for hundreds of comparable structures. That is how large this single empty region is. And within this colossal volume, astronomers have found fewer than 60 galaxies. 60. In a sphere of space capacious enough to swallow thousands of galaxy clusters without noticing. For comparison, a region of average cosmic density at that size should contain roughly 10,000 galaxies. Some estimates run higher. The boat's void contains less than 1% of what it should. It is not slightly underdense. It is catastrophically empty. A cosmic desert so barren that its discovery in the early 1980s genuinely shocked the astronomical community. Nothing in the standard models of the time predicted that emptiness could be organized on such a monstrous scale. If our solar system existed at the center of the Boötes void, the experience of looking up at the night sky would be almost unrecognizable. The Milky Way would still surround us, because we would still be inside our own galaxy. But beyond it, the sky would be profoundly dark. The nearest neighboring galaxy would be so distant and so faint that it might not have been detected until well into the 20th century, when telescopes became powerful enough to reach those extreme distances. For most of human history, civilizations at the center of the Boötes void would have had no idea that other galaxies existed at all. They would have looked out at the cosmos and seen only their own galaxy, surrounded by a blackness so total and so vast that the universe itself would have seemed like a single island of light floating in an infinite ocean of nothing. And the Boötes void is not even the largest void astronomers have found. The KBC void, named for the 3 astronomers who characterized it in 2013, may extend up to 2 billion light-years across, with our own Milky Way sitting somewhere near its interior, possibly offset a few 100 million light-years from the center. The Eridanus supervoid stretches roughly 1.8 billion light-years in diameter and was detected partly through its effect on the cosmic microwave background radiation, the ancient afterglow of the Big Bang. These are not small holes in an otherwise solid structure. These are the dominant features of the cosmic landscape. They are the rule. The galaxies and filaments are the exceptions. Why does the universe look like this? Why is cosmic structure organized into thin webs surrounding enormous voids, rather than being distributed smoothly or randomly? The answer reaches back to the earliest moments of existence. In the first fraction of a second, after the Big Bang, the universe underwent a period of extraordinary expansion called inflation. During this epoch, which lasted an almost inconceivably short time, perhaps 10 to the negative 36th seconds, quantum fluctuations in the energy density of space were stretched from subatomic scales to cosmic scales. These fluctuations were unimaginably tiny, variations of perhaps 1 part in 100,000, barely detectable even with the most precise instruments ever built. But they were there, and they mattered. After inflation ended, the universe continued expanding, but now gravity began to work on those tiny density variations. Regions that started with slightly more matter than average had slightly stronger gravitational pull. They attracted more matter from their surroundings, which made them denser, which increased their gravitational pull further, which attracted still more matter. This is gravitational instability, a positive feedback loop that amplified barely perceptible initial ripples into dramatic concentrations of mass over hundreds of millions of years. Meanwhile, the opposite happened in regions that started slightly less dense than average. These underdense patches had slightly weaker gravity. They could not hold on to their matter as effectively as their denser neighbors. Material drained away from them, pulled toward the collapsing overdense regions. As matter left, the underdense regions became even emptier. Their gravity weakened further. More matter escaped. The process fed on itself in both directions. Dense regions got denser. Empty regions got emptier. Over billions of years, the initial quantum whispers of the Big Bang were amplified into the grand cosmic web we observe today. Voids are not accidental gaps in the universe. They are not places where matter simply failed to show up. They are the gravitational consequence of structure formation itself. They are the other side of the coin. Every filament of galaxies exists because matter was pulled out of the surrounding volume. Every galaxy cluster formed because gravity drained material from the regions around it. The voids are what is left behind after gravity has done its work. They are the scars of cosmic construction, the abandoned quarries from which the building materials of galaxies were extracted. They are as inevitable and as fundamental as the structures themselves. You cannot have filaments without voids. You cannot have galaxy clusters without the empty regions that fed them. The two are inseparable halves of the same process. The cosmic microwave background radiation provides a direct snapshot of this process frozen in time. This radiation, emitted when the universe was only 380,000 years old and space first became transparent to light, carries a faint but unmistakable imprint of the original density variations that seeded all structure. Warmer spots in the cosmic microwave background correspond to regions that were slightly denser than average when the radiation was released. Cooler spots correspond to regions that were slightly less dense. The differences are extraordinarily small, only a few 100,000ths of a degree, but they are there. Satellites like the Planck spacecraft, launched by the European Space Agency, have mapped these temperature differences across the entire sky with precision measured in millionths of a degree, revealing the seeds of everything that would follow in exquisite, breathtaking detail. The warm spots became the filaments and clusters. The cool spots became the voids. Every void you can identify in a modern galaxy survey traces its origin to a cold spot in the cosmic microwave background, a region of slightly lower density that was destined from the beginning to be emptied by gravity. Every filament traces its ancestry to a warm one, a patch of slightly higher density that was destined to collect the matter draining out of its neighbours. The structure was written into the universe from the very beginning, encoded in quantum fluctuations that occurred before atoms existed, before stars existed, before anything we would recognise as chemistry or physics or matter had taken form. But the formation of voids is not a finished process. It is ongoing, and it is accelerating. Here is where dark energy enters the story. Dark energy is the name given to the mysterious component of the universe that drives the acceleration of cosmic expansion. It comprises approximately 68% of the total energy content of the cosmos, dwarfing both ordinary matter and dark matter combined. Its nature remains one of the deepest unsolved problems in physics, but its effects are measured, confirmed, and relentless. In regions of the universe where matter is concentrated, in filaments and galaxy clusters and superclusters, gravity pushes back against cosmic expansion. The mutual gravitational attraction between galaxies and dark matter halos resists the stretching of space, holding structures together, slowing the local expansion rate, maintaining the integrity of bound systems. Galaxy clusters do not fly apart because the gravity within them is strong enough to counteract the outward pressure of expanding space. This gravitational resistance is what keeps the cosmic web intact, but in voids, gravity has almost nothing to work with. The matter density is so low that gravitational attraction is negligible. There are no massive galaxy clusters pulling things together, no rich concentrations of dark matter creating deep gravitational wells, no filaments of gas-channeling material into collapsed structures. The voids are gravitational deserts where the force that holds the rest of the universe together is effectively absent. And in the absence of gravity, dark energy faces no opposition, it wins. Completely, decisively, and permanently. The result is that voids expand faster than the rest of the universe. Space within voids stretches at a rate that exceeds the cosmic average, because there is no gravity to slow it down. Think of gravity and dark energy as two opponents in a tug of war. In dense regions, gravity pulls hard, and dark energy can barely budge the rope. In voids, gravity has almost no grip. Dark energy yanks the rope freely, stretching space outward with no resistance. The voids grow. Their boundaries push outward. The thin walls of galaxies surrounding them get stretched thinner and thinner with every passing epoch. Matter that sits near the edges of voids feels the gravitational pull of the denser regions outside and beyond, accelerating away from the void center and toward the filaments. This outflow further depletes the void, making it emptier, which reduces its gravity further, which allows dark energy to push even harder. The process is self-reinforcing and irreversible. Voids that are empty become emptier. Voids that are large become larger. The cosmic web does not tighten over time. It loosens. The bubbles inflate. The soap film stretches thinner. The architecture of the universe is slowly, systematically dismantling itself. Scientists have confirmed this through direct observation. By measuring the velocities of galaxies near void edges and comparing them to galaxies in denser regions, researchers have detected the outflow pattern predicted by theory. Galaxies near void centers move away from those centers faster than cosmic expansion alone would explain. They are being evacuated, pulled outward by the gravitational imbalance between the nearly empty void interior and the denser structures surrounding it. Our own galaxy participates in this process. The Milky Way is moving away from a nearby underdense region called the local void at roughly 600,000 miles per hour, driven by the gravitational tug of denser structures in the opposite direction. We are, in a very real physical sense, fleeing from emptiness. This accelerating expansion of voids means that the universe is becoming emptier over time, not fuller. The fraction of cosmic volume occupied by voids is increasing. The filaments are thinning. The walls between voids are being stretched. Structures that are not gravitationally bound, meaning structures larger than individual galaxy clusters, will eventually be pulled apart by the relentless expansion of the voids surrounding them. The cosmic web is not a permanent fixture of the universe. It is a temporary phase, a snapshot of a process that began with quantum fluctuations and will end with the complete dissolution of large-scale structure into isolated islands of matter surrounded by ever-expanding oceans of nothing. Billions of years from now, the voids will have consumed most of the cosmic web. Filaments that currently connect distant superclusters will have snapped like overstretched rubber bands. Galaxy groups that are not bound tightly enough by their own internal gravity will have drifted apart, their members carried away from one another by the expanding void between them. Superclusters, those enormous collections of galaxy clusters that span hundreds of millions of light years, will dissolve. They are not gravitationally bound. They are loose associations held together only by proximity, and proximity is exactly what the voids destroy. The only structures that will survive this cosmic dissolution are those held together by gravity strong enough to resist the expansion permanently. Individual galaxy clusters, perhaps. Local groups like our own, where the Milky Way and Andromeda and their small companions are bound tightly enough to persist as a single gravitational system even as the universe expands around them. Everything else will be carried away into the growing void, receding beyond the cosmic horizon, accelerating away faster than light itself can travel, lost to observation and lost to any possibility of contact forever. The universe will become a collection of isolated gravitational islands floating in an ever-deepening, ever-darkening sea of emptiness. Not because matter is being destroyed, not because stars are going out, but because the emptiness between matter is growing faster than anything can cross it. The void is not consuming the matter. It is consuming the space between the matter, and in doing so, it is severing every connection, every line of sight, every possible communication channel between one island of substance and the next. This is not speculation. This is the confirmed trajectory of cosmic evolution under the standard model of cosmology: lambda, cold, dark matter. Dark energy is measured. Its effects are observed across billions of light years. The acceleration of cosmic expansion is documented by multiple independent research groups using multiple independent methods. The growth of voids is predicted by every major simulation of structure formation and confirmed by every large-scale galaxy survey that has ever been conducted. The future of the universe is not more structure. It is less. Not more connection between distant regions. Less. Not more light reaching across the cosmic web. Less. The voids are winning. They have been winning since the quantum fluctuations that seeded them were first stretched across the infant cosmos during inflation, and they will continue winning, patiently and relentlessly, until the cosmic web is nothing but isolated fragments drifting in an infinite emptiness, separated by distances that no signal, no spacecraft, and no beam of light can ever cross. But there is something even more unsettling buried in this picture of cosmic architecture, something that most descriptions of the cosmic web gloss over or ignore entirely. We have established that voids are enormous, dominant, and growing. We have established that galaxies and filaments are thin, fragile, and confined to the minority of cosmic volume. But the natural response to this information is to think of the cosmic web the way you might think about a city. Sure, most of the land area might be desert or ocean, but the city itself, the part where people live and work, is dense and rich and full of activity. The voids might be vast, but the filaments are busy. This response feels comforting, and it is wrong, because the filaments themselves, the walls and threads and clusters that contain the galaxies, the bright parts of the cosmic web, the structures we photograph and celebrate and study, are not dense. They are not packed. They are not full in any humanly meaningful sense. They are thin beyond imagination, fragile beyond comprehension. A filament of the cosmic web can stretch for hundreds of millions of light years while maintaining a width of only 20 or 30 million light years. They are strikingly elongated, thin threads of matter stretched across distances that dwarf all comprehension. And within that filament, the galaxies are not shoulder to shoulder. They are separated by millions of light years of nearly empty intergalactic space, drifting through a medium so sparse that it barely qualifies as matter at all. Even the densest nodes of the cosmic web, the great galaxy clusters where thousands of galaxies swarm around a common center of gravity, are overwhelmingly empty. The space between galaxies within a cluster is filled with hot, intracluster gas heated to tens of millions of degrees, but this gas is so diffuse that it contains only about 1/1000th of one atom per cubic centimeter. It glows in X-rays and contains more mass than all the visible galaxies in the cluster combined, yet it is thinner than the thinnest whisper of atmosphere on the most desolate moon in our solar system. The bright parts of the cosmic web are not dense oases surrounded by desert. They are slightly less empty deserts surrounded by even emptier desert. The filaments and clusters are improvements over the voids, yes. They contain more matter. They glow. They produce stars and planets and the chemistry of life. But they are not full. They are not crowded. They are not busy in any way that would satisfy a human being standing inside them and looking around. They are marginally less empty than the voids they border. That is the most generous description available. This realization cuts to the heart of why space feels so empty. The universe does not have a problem of insufficient objects. It has 2 trillion galaxies. It has a septillion stars. It has numbers so large they lose all meaning when spoken aloud. The problem is that even these staggering populations of objects cannot fill the volume they occupy. The cosmos is too large, the distances are too great, the space between things is too dominant. Even when matter gathers into the densest concentrations gravity can produce, even when galaxies pile up by the thousands into clusters that span millions of light years, the result is still a structure that is overwhelmingly, structurally, definitionally empty. The cosmic web is the largest and most dramatic structure in the universe. It spans the entire observable cosmos. It contains every galaxy, every star, every world. And its primary ingredient, the thing it is mostly made of, the substance that fills 4/5 of its total volume and dominates even the remaining fifth, is nothing. Vacuum. Void. Absence. This is the architecture of the universe. Not a cathedral of light, not a grand hall of matter and energy. A foam of emptiness with the thinnest possible tracery of substance clinging to the walls of its bubbles. And even those walls, examined closely, turn out to be almost as empty as the voids they pretend to separate. What comes next strips away the last refuge of intuition, because if even the cosmic web, the grandest structure in existence, is mostly void, then surely the objects within it, the individual galaxies, the star clusters, the nebulae, the things we see glowing in telescope images, must be genuinely full, genuinely dense, genuinely packed with matter. They look solid, they look rich, they look like the real substance of the cosmos. They are not. And the next part of this story reveals exactly how empty even the brightest, most dramatic objects in the universe truly are. There is a natural defense mechanism that kicks in at this point in the story, a mental refuge that the brain retreats to when confronted with the staggering emptiness of intergalactic space and the void-dominated architecture of the cosmic web. The defense goes something like this. Fine. The spaces between galaxies are empty. The voids are enormous. The cosmic web is mostly hollow, but the galaxies themselves, the actual structures where stars and planets exist, those are dense. Those are full. Those are the real substance of the universe, the places where matter concentrates and light shines and things actually happen. The emptiness is out there, in the gaps, in the margins, in the spaces between the interesting parts. But inside the galaxies, inside the nebulae, inside the star clusters that glow in telescope photographs, there is genuine density, genuine substance, genuine fullness. This defense feels reasonable. It feels like solid ground after a long walk through cosmic desert, and it is completely, devastatingly wrong. Because the galaxies are not full either. The nebulae are not dense, the star clusters are not packed. Even the brightest, most dramatic, most visually stunning objects in the entire universe, the structures that define our image of a rich and populated cosmos, are overwhelmingly, structurally, almost entirely empty. The dominance of emptiness does not stop at the borders of galaxies. It penetrates them. It defines them. It is their most fundamental physical property, more fundamental even than the stars they contain. Start with our own galaxy. The Milky Way is a barred spiral galaxy, approximately 100,000 light-years in diameter, and roughly 2,000 light-years thick at the disk. It contains somewhere between 200 billion and 400 billion stars, depending on which estimate you trust and how you count the dim red dwarfs that make up the majority of the stellar population. Those numbers feel enormous. They feel like the description of a crowded, thriving, densely packed city of suns. But consider the volume those stars occupy. The Milky Way's disk alone encompasses roughly 15 trillion cubic light-years of space. That is a number that resists comprehension. A volume so vast that even light, the fastest thing in physics, would need tens of thousands of years to cross it. Divide the number of stars by the volume, and you get the average stellar density. In our neighbourhood of the galaxy, the solar neighbourhood, that density works out to approximately 1 star for every 260 cubic light-years. 1 star. In a volume of space roughly 6.5 light-years on a side. One solitary nuclear furnace burning alone in a cube of vacuum wide enough that light needs more than 6 years to cross it. Your nearest stellar neighbour is separated from you by a gulf so wide that the fastest spacecraft ever launched by human civilization would need millennia to bridge it. And this is not a particularly lonely part of the galaxy. This is average. This is normal. This is what the interior of a galaxy looks like when you measure it honestly instead of photographing it selectively. To feel what this means, imagine shrinking the entire Milky Way down to a scale you can walk around in. Reduce the galaxy until it fits inside a large cathedral, say a building about 500 feet long and 200 feet wide and 150 feet tall. At this scale, each star in the galaxy would be far smaller than a single atom. Not a grain of sand, not a speck of dust, not a bacterium or a virus or a molecule. Smaller than an atom, smaller than a wavelength of light. The cathedral would appear completely empty to any human sense and any human instrument. You could walk through it for hours, sweep your hands through the air, run your fingers along every surface and find absolutely nothing. No visible matter at all. No detectable substance of any kind. The stars would be there, hundreds of billions of them, but they would be so impossibly tiny relative to the space containing them that no instrument you could carry, no microscope you could build, would detect a single one. The galaxy that looks so rich and grand in wide-field astrophotographs would be, at human scale, indistinguishable from a perfect vacuum. This is not an exaggeration designed for dramatic effect. This is the literal physical reality of stellar density inside a galaxy. Stars are extraordinarily small compared to the distances between them. Our Sun is roughly 860,000 miles in diameter. That sounds enormous, and by planetary standards it is. But the distance to the nearest neighbouring star is approximately 25 trillion miles. The ratio of stellar diameter to interstellar distance is roughly 1 to 29 million. The Sun is a marble floating in a space 29 million marbles wide, with nothing between it and the next marble. This ratio holds approximately throughout much of the Milky Way. Galaxies are not containers full of stars. They are containers full of emptiness that happen to have stars sprinkled through them at intervals so sparse that the stars themselves are cosmically irrelevant to the volume they inhabit. Now push the analysis to the most extreme case. What about the densest stellar environments known to exist? If ordinary regions of the galaxy are this empty, surely the places where stars are genuinely crowded must be different. Surely the cores of globular clusters, those ancient balls of hundreds of thousands of stars packed into relatively small volumes, must be dense enough to feel full. They are not. The core of Messier 15, one of the densest globular clusters in the Milky Way, packs approximately 4 million stars into each cubic parsec, a unit of volume roughly 3.26 light-years on a side. That is 75 million times denser than the solar neighbourhood. It sounds impossibly congested. It sounds like stars must be practically touching, rubbing shoulders, colliding in a blaze of superheated plasma and blinding radiation. If anywhere in the galaxy qualifies as crowded, as genuinely full of matter, it must be this. The core of the densest star cluster we can measure should be the one place in the Milky Way where emptiness finally loses. The reality is sobering. Even at this extreme density, the average distance between neighbouring stars in the core of Messier 15 is approximately 860 astronomical units. 1 astronomical unit is the distance from the Earth to the Sun, about 93 million miles. 860 astronomical units is roughly 80 billion miles. That is more than 21 times the distance from the Sun to Pluto, more than 20 times the distance from the Sun to Neptune. You could line up entire planetary systems in the gaps between stars and have room to spare. In the densest stellar environment ever measured in our galaxy, stars are still separated by gulfs so wide that entire solar systems could fit between them multiple times over without any overlap whatsoever. An observer stationed at the core of Messier 15 would see a spectacular night sky, unlike anything visible from Earth. Thousands of brilliant stars would blaze in every direction, some close enough to cast visible shadows, some bright enough to rival a full moon. The sky would glow with a diffuse background radiance from the sheer number of nearby suns. It would be beautiful. It would be overwhelming, and it would still be almost entirely empty space. Between every pair of blazing stars, you would find billions of miles of vacuum. You could fly a spacecraft in any direction and travel for months at the speed of light before brushing close to a single stellar surface. The densest stellar environment in the Milky Way is still overwhelmingly, definitionally, structurally empty. The stars are brighter there, they are closer together, but the space between them still dominates, still rules, still constitutes the vast majority of everything that exists within the cluster. Emptiness does not yield even in the most extreme concentrations of stars the galaxy can produce. This pattern extends to every type of astronomical object that appears dense or full in photographs. It extends to structures that are not even made of stars but of gas and dust, the raw material of star formation. Consider nebulae. The Orion Nebula is one of the most photographed objects in the night sky and one of the most visually spectacular. It appears in telescopic images as a thick, luminous cloud of gas and dust, glowing with the pink and orange hues of ionized hydrogen, streaked with dark lanes of absorbing dust, sculpted by the radiation of young stars embedded within it. It looks substantial. It looks solid almost, like a cosmic thunderhead, a dense fog of material lit from within by newly born suns. If any structure in the galaxy looks full of matter, it is a nebula. Gas and dust everywhere, in every direction, so thick that it blocks the stars behind it and glows with its own internal light. Surely this is matter in bulk. Surely this is the universe at its most concentrated outside of a star itself. The Orion Nebula has a particle density of roughly 100 to 10,000 particles per cubic centimetre, depending on which region you measure. The densest knots and filaments within the molecular cloud behind the visible nebula can reach somewhat higher concentrations, perhaps 100,000 particles per cubic centimetre in the darkest, coldest cores where new stars are actively forming. These numbers sound respectable until you compare them to anything in human experience. The atmosphere you are breathing at sea level on Earth contains approximately 25 million trillion molecules per cubic centimetre. That is 25 followed by 18 zeros. The densest region of the Orion Nebula, the most concentrated clump of matter in the thickest part of the cloud, contains at most 100,000 particles in that same volume. Let that comparison settle in your mind for a moment. The air in your lungs right now is roughly 250 trillion times denser than the thickest, most opaque, most visually dramatic portion of the Orion Nebula. And the typical regions of the nebula, the parts that glow so brilliantly in photographs, are thousands of times less dense still. A nebula that looks like a solid wall of glowing gas in a long exposure photograph is actually a vacuum so extreme that no laboratory on Earth has ever achieved anything remotely close to it. Not by any comfortable margin. The best vacuum chambers ever constructed by human engineering contain roughly 100 times more matter per unit volume than the faintest visible regions of the Orion Nebula. If you could scoop up a cubic kilometre of the Orion Nebula and compress all the material within it into a solid mass, the result would weigh less than a milligram. A volume the size of a mountain range would weigh less than a single raindrop. The nebula is not a cloud in any physically meaningful sense. It is a mathematical whisper of density, a statistical suggestion of substance that only appears thick and luminous because it stretches across light years of space and is energized by the ultraviolet radiation of newborn stars. Remove the starlight, and the nebula becomes invisible, indistinguishable from the vacuum surrounding it. Compress it to any volume a human could perceive, and it vanishes entirely. There is almost nothing there. The beauty is real. The substance is not. This reveals one of the most important and least discussed truths about how humans perceive the cosmos. It is a truth that affects not only the general public, but professional astronomers, textbook authors, documentary filmmakers, and everyone else who has ever tried to communicate what the universe is like. Every image of space you have ever seen is a lie, not a deliberate lie, not a fabricated deception, not a hoax designed to mislead, but a lie of selection so profound, so structural, so built into the very nature of observation itself, that it distorts your understanding of reality at the most fundamental level possible. Telescopes and cameras detect light. They collect photons, the particles of electromagnetic radiation emitted by stars, reflected by planets, and scattered by gas and dust. They focus those photons onto detectors that assemble images, and those images show you where the photons came from. They show you the stars, the nebulae, the galaxies and clusters that populate the minority fraction of cosmic volume where matter has concentrated. What they cannot show you is the emptiness. Emptiness does not emit radiation. It does not reflect, scatter, or absorb light. It is invisible by definition, the one thing that imaging technology is fundamentally incapable of recording. You cannot photograph nothing, and the universe is almost entirely nothing. This means that every photograph of the cosmos is a photograph of the exceptions, the rare, scattered, cosmically insignificant concentrations of matter that happen to produce or interact with light. The overwhelming majority of the universe, the vacuum that fills more than 99.9999% of all cosmic volume, is absent from every image ever taken. It is absent from every survey ever conducted. It is absent from every map ever drawn. When you look at a stunning photograph of the Milky Way stretching across the night sky, dense with stars, rich with nebulae, glowing with the combined light of hundreds of billions of suns, You are looking at a picture of less than 1/1000th of the galaxy's actual volume. Everything else, the emptiness that dominates every cubic light-year of galactic space, is invisible, not hidden behind something, not obscured by dust or gas. Invisible, structurally undetectable by the instruments we use to see. You have never seen a photograph of the universe. You have seen photographs of the tiny fraction of the universe that emits light. The difference between these two things is the difference between photographing a city and photographing only the light bulbs in a city, and then concluding that the city is made of light bulbs. The buildings are missing from your photograph. The streets are missing. The parks, the rivers, the sidewalks, the empty lots, the parking garages, the air itself. The vast majority of the physical structure of the city is absent from the image. What remains is a scattering of bright points that tells you almost nothing about the actual environment in which those points exist. You know where the lights are. You know nothing about the darkness between them, and the darkness is where most of the city actually is. This observational bias has shaped human understanding of the cosmos for as long as humans have looked at the sky, and it continues to shape it today despite everything science has revealed. When astronomers describe the universe, they describe the things they can see. Stars, galaxies, nebulae, clusters, quasars, pulsars, supernova remnants. These are the objects that populate textbooks, documentaries, scientific papers, and public lectures. They are the characters in every story we tell about the cosmos. They are the subjects of every press release, every discovery announcement, every space telescope image shared on social media, and they create an overwhelming, persistent, almost inescapable impression that the universe is full of stuff, packed with things, crowded with objects and events and phenomena. Because every time we point a telescope at the sky and take a picture, we see stuff. Bright, beautiful, intricate, colourful stuff arranged in spectacular patterns across billions of light years. But the stuff is not the universe. The stuff is the garnish, the decoration, the sprinkle of matter that clings to the edges of a cosmos whose fundamental substance is emptiness. We photograph the 1% and mistake it for the whole. We study the exceptions and conclude they are the rule. We see the light and forget the darkness that contains it. We are a species that evolved to notice what is there and ignore what is not. And this evolutionary habit has blinded us to the most basic truth about the cosmos we inhabit. This brings us to the most sobering number in all of cosmology, the single figure that, more than any other, captures the true nature of the universe we inhabit. It is not a measurement of distance, or of time, or of the number of galaxies. It is a measurement of density, the average density of the observable universe. If you could take every particle of matter in the observable universe, every atom, every subatomic particle, every fragment of ordinary baryonic matter that exists in any form, anywhere in the cosmos, every star, every planet, every gas cloud, every grain of dust, every cosmic ray, every molecule of interstellar and intergalactic gas, every neutron in every neutron star, and every proton in every white dwarf, everything, and distribute it perfectly evenly throughout the entire observable volume of space, how dense would the resulting substance be? The answer is approximately 1 proton per 4 cubic meters. One single proton, the nucleus of a single hydrogen atom, in a space the size of a large closet or a small bathroom, surrounded by nothing, floating alone in a vacuum with the nearest neighbouring proton drifting somewhere in the next closet, 4 cubic meters away in its own lonely pocket of emptiness. This is the average baryonic density of the observable universe when you include both the dense regions and the voids, when you average the galaxy clusters with the cosmic deserts, when you smooth the filaments and the supervoids and the nebulae and the intergalactic medium into one uniform distribution across the entire 93 billion light-year diameter of observable space. 1 proton per 4 cubic meters. That is not merely sparse. That is not merely thin. That is a void so extreme that the word empty fails to capture it. It is the absence of substance, elevated to the defining characteristic of everything that exists. If you include dark matter and dark energy, the total energy density of the universe rises to the equivalent of roughly 6 protons per cubic meter. Dark matter outweighs ordinary matter by approximately 5 to 1, and dark energy accounts for another 68% of the cosmic energy budget. But even with everything included, the average density of the universe is breathtakingly low. 6 proton equivalents per cubic meter, in a volume that would fit inside a standard kitchen cabinet, and dark matter, whatever it ultimately turns out to be, does not form stars. It does not create planets. It does not produce light or chemistry or life. It does not interact electromagnetically. It does not collide with atoms or scatter off molecules or participate in any process that human senses or human instruments can detect directly. It is gravitationally significant but physically inert as far as human experience is concerned. It shapes the scaffolding of the cosmic web but contributes nothing to the warmth, the light, the chemistry, or the complexity that makes the universe interesting to beings like us. The average density of the things that actually make up our world, the atoms that form rocks and water and air and DNA and the voice you are hearing right now, is 1 proton per 4 cubic meters of space. To understand what this means in terms a human body can process, consider that the air in a typical room on the surface of the Earth contains roughly 10 to the 25th particles per cubic meter. That is a 1 followed by 25 zeros. Roughly 10 trillion atoms in every cubic meter of the air around you right now. The average cosmic density of ordinary matter is approximately 25 orders of magnitude lower than the air you are breathing. 25 orders of magnitude is not a small difference. It is not a rounding error. It is the difference between a number and the same number divided by 10 trillion. The universe is not just empty compared to a planet or a room or a cloud of atmospheric gas. It is not just empty compared to a laboratory vacuum. It is empty compared to the emptiest empty that human technology has ever contemplated or could ever achieve. If you designed and built the most perfect vacuum chamber physically possible, evacuated every atom you could remove, cooled it to within a fraction of a degree above absolute zero, and shielded it from every source of contamination, the density inside that chamber would still exceed the average density of the observable universe by many orders of magnitude. The universe, taken as a whole and averaged across its entire volume, is the emptiest thing there is. Nothing is emptier than the cosmos, not by a little, not by a factor of 10 or 100, by factors of trillions upon trillions. The universe contains objects, yes, stars, galaxies, planets, nebulae, clusters, superclusters, the whole glittering catalogue of cosmic structures that astronomers have spent centuries documenting and celebrating. But those objects are exceptions, anomalies, statistical outliers in a cosmos whose fundamental state, whose default condition, whose overwhelming physical reality is vacuum, darkness, nothing. This is the truth that no photograph can show you, and no number can make you feel. The universe is not a sky full of stars interrupted by occasional patches of darkness. It is an ocean of darkness interrupted by occasional, vanishingly rare, cosmically insignificant sparks of light. The darkness is not the background. The darkness is the medium. The darkness is the substance. The stars are the interruptions. And the interruptions are so small, so infrequent, so hopelessly outnumbered by the emptiness that surrounds them, that they barely register in any honest accounting of what the universe contains. Every time you look up at the night sky and see a field of stars, your brain is lying to you. It is showing you the light and hiding the darkness. It is counting the exceptions and ignoring the rule. It is telling you a story about a crowded, populated, busy universe that does not exist and has never existed at any point in cosmic history. The real universe, the one that would appear if your eyes could see vacuum as clearly as they see light, if your retina could register emptiness as vividly as it registers a photon, would look nothing like the night sky you know. It would be black, almost perfectly, almost completely, almost terrifyingly black. Not the black of a dark room, which still contains air and walls and furniture you cannot see. The black of absolute absence, Emptiness so total and so pervasive that you could scan across billions of light years and find almost nothing at all, with faint, scattered, lonely points of light so rare and so widely separated that you could sweep your gaze across the sky for hours without finding a single one that registered as more than a distant, dying ember. That is the cosmos, not the version in the photographs, not the version in the textbooks, not the version rendered in planetarium projectors or documentary animations, or the computer-generated fly-throughs that make the universe look like a glittering metropolis of stars. The real version, the physical version, the one described by measurements and confirmed by mathematics and demonstrated by every instrument sensitive enough to probe the actual density of space, the one that exists whether you photograph it or not, whether you believe it or not, whether your brain can process it or not. And this reality raises a question that goes beyond physics, beyond astronomy, beyond any specific measurement of density or distance or volume. It raises the question of what it means to exist in a universe where emptiness is not a defect, not an absence, not a failure of the cosmos to fill itself with the matter it has produced, but the primary structural characteristic of everything that is. A universe that was built from the quantum fluctuations of its first instant to separate its contents so thoroughly and so completely that the contents themselves become almost irrelevant compared to the separations between them. A universe where the dominant experience, for any traveller crossing any distance at any scale, would not be the encounter with matter but the endless, crushing, featureless passage through the void between one speck of matter and the next. That question, and its deeply unsettling answer, is where this story reaches its final destination, because the reason space feels so empty is not, ultimately, a fact about distance or density or volume, or the number of atoms per cubic meter. It is a truth about architecture, about what the universe fundamentally is at every level of its construction, from the quantum to the cosmic. And that truth, once you see it clearly, changes everything you thought you knew about your place within it. We have travelled a long way to reach this moment. We began where every human begins, standing on a small planet, looking up at a sky filled with stars, and feeling the instinctive certainty that the universe is full. That certainty felt natural. It felt obvious. It was supported by every photograph, every telescope image, every documentary fly-through, every number that modern astronomy has produced. 2 trillion galaxies, a septillion stars, hundreds of billions of potentially habitable planets in our galaxy alone. The cosmos seemed not just populated but overflowing, rich beyond comprehension, dense with objects and light and activity in every direction. Then we learned that the number of objects is not the same thing as the distribution of objects. We discovered that stars are separated by trillions of miles of near-perfect vacuum, that the space between galaxies drops to densities so low they make the interstellar void look congested, that the entire solar system, with all its planets and moons and asteroids, fills less than 1/trillionth of 1% of its own volume. The universe was not as full as it looked, but we still had the cosmic web. We still had the galaxies. Then we learned that the cosmic web, the grandest structure in existence, is 80% void, that the filaments and clusters that contain the galaxies are thin, fragile minority structures draped across the surfaces of enormous empty bubbles, that those voids are not accidental gaps but the gravitational consequence of structure formation, carved into the cosmos since the quantum fluctuations of the first instant. That dark energy is expanding the voids, accelerating their growth, systematically dismantling the connections between distant regions. The galaxies were islands, the web was mostly ocean. Then we learned that even the islands are empty, that galaxies are overwhelmingly vacuum with a few scattered specks of stellar matter sprinkled through them at absurdly sparse intervals, that the densest star clusters in the Milky Way still have gaps measured in tens of billions of miles between neighbouring suns. That nebulae, those glowing icons of cosmic richness, are vacuums so extreme they surpass anything humans have ever engineered. That the average density of the entire observable universe, when you smooth all its matter into an even distribution, works out to a single proton floating alone in a space the size of a closet. Every layer of the story has led to the same conclusion. Every scale of analysis has produced the same result. Every time we thought we had found the part of the universe that was genuinely full, the measurement came back the same way. Empty. Overwhelmingly, structurally, definitionally empty. And now we reach the final question. The question that gives this story its meaning and separates it from a simple catalogue of cosmic statistics. The question is not how empty is space. We have answered that. The question is, why does it matter? It matters because the emptiness of space is not a detail. It is not a footnote to a more interesting story about stars and galaxies and planets. It is the story. Emptiness is not what lies between the objects that make up the universe. It is the primary substance of the universe itself. The cosmos was not built as a filled environment with some gaps. It was built as an emptiness with some exceptions. The gap is the architecture. The gap is the design. The gap is the fundamental structural principle upon which everything else, every star, every world, every atom of matter, every flash of light, is merely a tiny, temporary, cosmically insignificant deviation. This is what it means to say that space feels empty. It does not mean that space lacks objects. It does not mean that the universe is barren or lifeless or devoid of interesting phenomena. It means that the distances between objects are so overwhelmingly, so structurally, so irreducibly vast that the objects themselves become secondary to the separations. You can fill the cosmos with a septillion stars, and the separations still win. You can populate the observable universe with 2 trillion galaxies, and the voids still dominate. You can discover 100 billion potentially habitable worlds in the Milky Way, and the space between those worlds will still be the defining experience of any being that tries to reach one from another. The universe is not empty because it lacks content. It is empty because it is built to separate its content so thoroughly that the content becomes lost inside the separation. This is not a poetic interpretation. It is a physical fact. And it has consequences that cut to the deepest levels of what it means to exist as a conscious being in this cosmos. Consider what the emptiness of space means for travel. Not hypothetical travel. Not the comfortable science fiction of warp drives and hyperspace lanes and teleportation gates that fold space-time like a napkin. Real travel. Travel bounded by real physics, constrained by the actual speed limit of the universe, subject to the laws of thermodynamics and relativity and energy conservation that no amount of technological progress can repeal. The fastest thing in existence is light. Nothing with mass can reach the speed of light. Nothing without mass can exceed it. At 670 million miles per hour, light represents the absolute ceiling of velocity in our universe, a boundary imposed not by engineering limitations that might someday be overcome, but by the fundamental geometry of space-time itself. Einstein's special relativity does not say that light speed is hard to achieve. It says that achieving it requires infinite energy. It is not a wall that a sufficiently advanced civilization could break through. It is a feature of the universe as basic as the existence of matter itself. And even light, travelling at this maximum possible speed, the fastest anything can ever move in the history of existence, needs 4 years to reach the nearest star, needs 26,000 years to reach the centre of our own galaxy, needs 2.5 million years to reach the nearest large galaxy, needs 13.8 billion years to cross the observable universe from one side to the other. And even then, it only completes the journey, because the universe was far smaller when the light began travelling. For any traveller moving at speeds that matter and energy can actually achieve, the emptiness of space is not an inconvenience. It is not a challenge to be engineered around. It is a prison. A spacecraft travelling at 1% of the speed of light, approximately 6.7 million miles per hour, a velocity that surpasses every propulsion technology currently in development or serious planning, would need over 400 years to reach the nearest star system. The crew that launched would be dead centuries before arrival. Their grandchildren would be dead. Their great-great-great-grandchildren would be dead. The civilization that built the ship might not survive long enough to remember why it was sent, and the nearest star is practically next door by galactic standards. The nearest confirmed potentially habitable exoplanet might be tens of light years away, requiring thousands of years of flight at this impossible speed. The nearest intelligence, if it exists at all, could be hundreds or thousands of light years distant, requiring tens of thousands of years of continuous travel through the blackest, emptiest, most featureless environment in all of nature. At real speeds, these are not journeys measured in human lifetimes. They are journeys measured in geological epochs. The emptiness between destinations is so vast that crossing it would require commitments longer than the entire recorded history of human civilization multiplied many times over. And that is just within our galaxy. Between galaxies, the distances escalate to the point where even light-speed travel becomes effectively meaningless on any timescale a mortal species could contemplate. Crossing from the Milky Way to Andromeda at the speed of light would require 2.5 million years. 2.5 million years of flying through intergalactic space, so empty that less than 1 atom per cubic meter would greet you. 2.5 million years of darkness so complete that no instrument aboard your ship could detect any object in any direction for the overwhelming majority of the journey. You would leave as one species and arrive, if you arrived at all, as something unrecognizably different. The emptiness of space does not merely make travel difficult, it makes connection nearly impossible. And connection, the ability of one point in the universe to communicate with, influence, or even know about another point, is the foundation of everything that matters to conscious beings. Knowledge, culture, relationship, community, meaning. All of these require connection. All of them require the ability to bridge the gap between one island of matter and another. And the cosmos, through its fundamental architecture of emptiness, makes that bridging almost impossibly hard. This is the emotional weight of cosmic emptiness. It is not about the cold statistics of density or the abstract numbers of interstellar distance. It is about what those statistics and numbers mean for beings like us. Beings that need connection in order to find purpose. Beings that evolved in tribes and villages and cities, surrounded at all times by other minds, other voices, other lives pressing close. We evolved on a planet where everything is close, where light crosses any distance in an imperceptible fraction of a second, where sound carries from one person to another in the time it takes to draw a breath, where you can reach out your hand and touch another living being without effort, without delay, without even thinking about the physics that makes contact possible. The universe in which our brains evolved, the universe of plains and forests and oceans and villages and campfires surrounded by familiar faces, is a universe of proximity, of density, of easy, immediate, constant contact between objects and between minds. Everything we are, everything we value, everything we build and love and fight for is rooted in the assumption that the universe is a place where things can touch. The actual universe is the opposite of this in every possible way. It is a universe of isolation, of separation so extreme it numbs the mind, of distances so vast that contact between neighbouring islands of matter requires efforts that dwarf the combined resources of entire planetary civilizations. We evolved to expect crowding, and the cosmos gave us exile. We evolved to expect connection, and the cosmos gave us walls of vacuum trillions of miles thick between ourselves and the nearest possible neighbour. We evolved to expect warmth and closeness, and the presence of others, and the cosmos gave us the coldest, darkest, most featureless emptiness that physics permits. Our brains are wired for a universe that does not exist, a universe of proximity and fullness, and the comforting illusion that there is always something nearby. The universe that does exist is built on emptiness so vast, so absolute, and so structurally permanent that even naming it feels like trying to describe an ocean by pointing at a single drop of water, and the isolation is growing worse. We have already seen how dark energy is accelerating the expansion of cosmic voids, how the gaps between galaxy clusters are widening, how filaments are thinning, how structures not held together by strong local gravity will eventually drift beyond each other's cosmic horizons, lost to observation, lost to contact, lost to any form of influence or communication forever. This process is not slowing down, it is speeding up. The expansion of the universe is accelerating, which means the rate at which emptiness grows is increasing with every passing moment. What this means in practical terms is that the universe is becoming lonelier, not just emptier, though it is becoming that as well. Lonelier in the deepest sense that matters to conscious beings, in the sense of connection being severed, of possibilities being foreclosed, of doors being closed that can never be opened again. The number of galaxies any observer can see, can reach, can theoretically communicate with across the gulf of space and time is shrinking. Right now, from our position in the cosmos, we can observe roughly 2 trillion galaxies. In 100 billion years, the number visible to any observer in our gravitational neighborhood will have collapsed to the few thousand galaxies that make up our local bound system, the objects held together tightly enough by their mutual gravity to resist the expansion of space. Everything else, every other galaxy, every other cluster, every other filament of the cosmic web that we can currently observe and study and wonder about, will have receded past the cosmic horizon, carried away not by motion through space, not by any force pushing them, but by the relentless, accelerating, utterly indifferent expansion of the emptiness between us. They will not explode, they will not collapse, they will not be destroyed, they will simply drift. Slowly, steadily, irreversibly, they will be carried beyond the point where their light can ever reach us. They will still exist. They will still burn with the light of billions of stars, but no photon they emit will ever complete the journey to our location, because the space between us will be expanding faster than light itself can cross it. They will become ghosts, present in reality but absent from observation, real but unreachable, existing but unknowable. The universe will not destroy its own contents. It will do something worse. It will isolate them from each other so completely that they might as well not exist at all. A civilization arising in that far future cosmos would look out at the universe and see almost nothing. Their sky would contain their own galaxy, perhaps a merged remnant of the Milky Way and Andromeda and a handful of smaller companions gravitationally bound into a single aging system. Beyond that, blackness. Total, featureless, unbroken blackness extending in every direction to the absolute limit of observation. No distant galaxies, no cosmic web, no filaments or clusters or walls of light stretching across the void. Nothing but the void itself, infinite and dark and utterly silent. They would have no evidence that other galaxies had ever existed, no photons arriving from beyond their local group, no cosmic microwave background radiation detectable in any wavelength, because its signal would have been stretched by expansion to frequencies below any conceivable instrument's sensitivity. They would have no way to deduce the Big Bang, no way to discover the expansion of the universe, no way to detect dark energy or measure the cosmic web, or learn any of the truths that we, living in this brief and extraordinary window of cosmic visibility, have been privileged to uncover. The very foundations of cosmology, the evidence for the origin and structure and fate of the universe, will have been erased by the expansion of the emptiness that cosmology describes. They would be cosmologically blind, epistemically imprisoned, trapped inside a single gravitational island, surrounded by an emptiness that offers no clues about the vastness it conceals. They would likely conclude that their galaxy was the entire universe, an island of aging light floating in an infinite, static, eternal void. They would be wrong, profoundly, tragically wrong, but they would have no way to know it. No observation they could make, no experiment they could design, no instrument they could build would reveal the truth that the void around them was once filled with 2 trillion galaxies, all of which had been carried away by the silent expansion of nothing. This is perhaps the most unsettling consequence of cosmic emptiness. It is not merely the current condition of the universe, it is the trajectory, the direction in which everything is heading. The arrow of cosmic evolution points toward increasing emptiness, increasing isolation, increasing separation between every gravitational system and every other one. It points toward a future in which connection between distant regions of the cosmos becomes not merely difficult, but physically, mathematically, permanently impossible. We happen to live at a moment in cosmic history when the universe is still young enough, still dense enough, still connected enough that we can see its structure, map its web, count its galaxies, and measure the expansion that is slowly pulling them all away from each other. This window of visibility is temporary. It will not last. The connections will sever, one by one, as distant galaxies accelerate past the cosmic horizon. The visible universe will shrink. The emptiness will grow until it swallows everything beyond the borders of our own gravitational neighborhood, leaving us alone in a cosmos that offers no evidence of the grandeur it once contained. We are living in the age of cosmic visibility, a brief, golden, unrepeatable window in which the universe still reveals its own history to anyone patient enough to look, and we are watching that window close. Now, step back from the future and return to the present. Return to where we started. Return to the simple, common, universal human experience of looking up at the night sky and feeling that the universe is full of stars. That feeling was never correct, but it was understandable. The brain does what evolution designed it to do. It detects light, it ignores darkness, it sees the exceptions and infers a pattern. It looks at 1,000 stars and concludes that space is crowded. It cannot help itself. Every neuron, every visual circuit, every cognitive shortcut that natural selection burned into the human brain over millions of years of evolution on a small, dense, busy planet screams the same message. Where there are things, there must be more things. Where there is light, there must be more light. Where there is presence, absence must be the exception. The cosmos says otherwise. The cosmos says that absence is the rule, that presence is the exception, that matter is rare, structure is fragile, connection is temporary, and emptiness is the baseline condition of everything that exists. The cosmos says that a universe can contain a septillion stars and still be experienced in any honest physical accounting as overwhelmingly, crushingly, structurally empty, not empty of objects, empty of proximity, empty of density, empty of the closeness that makes the presence of objects meaningful. The stars are there, the galaxies are there, the planets and the moons and the potential for life are there, but they are separated from each other by gulfs so wide, so devoid of substance, so hostile to connection, that their existence becomes almost theoretical to anyone standing on any one of them and looking outward. This is the real reason space feels so empty. It is not because the universe is small. It is incomprehensibly large. It is not because the universe lacks objects. It contains more objects than any language has numbers to express. It is not because the universe is dark, though it is dark. It is not because the universe is cold, though it is cold. It is not because the universe is hostile, though it is hostile in ways that make every other environment in human experience seem like a garden. Space feels empty because the universe was built less as a continuous filled environment and more as isolated islands of matter separated by overwhelming gulfs of darkness, vacuum, and distance. That is not a metaphor. That is the physical architecture of the cosmos, confirmed at every scale, at every distance, by every instrument that has ever measured it. The universe is a foam of emptiness, with thin, fragile threads of matter clinging to the walls of its bubbles. The bubbles are winning. They have always been winning. They will always win. And here is the thought that sits at the center of this entire story. The thought that makes the emptiness of space not just a scientific fact, but an emotional experience that stays with you long after you stop listening about density measurements and start going about your ordinary life on this small, warm, impossibly rare world. The universe did not fail to fill itself. Emptiness is not a mistake. It is not an oversight. It is not a gap waiting to be closed or a void waiting to be filled. The emptiness is the cosmos expressing its own nature. This is what a universe looks like when matter is created in a hot, dense burst and then allowed to expand and cool and clump and separate for 13.8 billion years under the influence of gravity and dark energy. This is what happens. You get structure, yes. You get stars and galaxies and the occasional rocky planet with liquid water and an atmosphere that can sustain the chemistry of life. But you get those things as tiny, vanishingly rare exceptions inside an emptiness so total, so dominant, so structurally overwhelming that calling it the background does not do it justice. Emptiness is not the background. Emptiness is the foreground. It is the main subject of the composition. The stars are the background. The galaxies are the background. All the matter and light and energy and life in the universe are the background. The fine print. The barely noticeable texture in a portrait whose subject is void. Every human who has ever lived has existed on one small planet, orbiting one ordinary star, in one spiral arm of one galaxy among trillions. That galaxy contains hundreds of billions of other stars, most of them probably orbited by planets, some of those planets possibly hosting life of their own. And all of it, every star, every planet, every moon, every grain of dust, every atom of gas, every flash of radiation, sits inside a universe that is, by volume, by mass, by every possible accounting, almost entirely made of nothing at all. You are hearing these words on a world that should not exist. Not because the physics is unlikely, though it is staggeringly unlikely. Not because the chemistry is improbable, though it required billions of years of stellar evolution to produce the heavy elements in your body. But because the world you inhabit is a concentration of matter so dense, so rich, so elaborately structured, so layered with complexity from core to atmosphere to biosphere, that it represents a deviation from the cosmic norm so extreme it borders on the absurd. You live on a planet where matter is packed so tightly that you cannot move a single inch without touching more of it, where the density of the ground beneath your feet exceeds the average density of the universe by roughly 30 orders of magnitude, where the air in your lungs is 25 orders of magnitude denser than the cosmic mean, where a single teaspoon of the ocean beneath your sky contains more atoms than the cosmic average assigns to a volume the size of a stadium. You live, breathe, think, and love inside a statistical anomaly of matter so extreme that the universe could search its own entire observable volume for billions of years and rarely find anything remotely comparable. And surrounding that anomaly in every direction, above you and below you, and in every orientation that three-dimensional space permits, stretches the real universe. The one made of emptiness, the one that defines everything, the one that separates your anomaly from the next nearest anomaly by distances so vast that the separation itself becomes the only truth worth stating. Space feels empty because it is empty, not empty of objects, empty of closeness, empty of contact, empty of the proximity that makes presence meaningful. The cosmos contains more objects than any mind can count, and it separates those objects so thoroughly, so absolutely, so permanently, that the separation overwhelms the presence. You can fill a universe with a septillion stars and the emptiness still wins. You can populate the cosmic web with 2 trillion galaxies and the void still dominate. You can discover that every fifth star has an Earth-sized planet in the habitable zone, and the distances between those worlds will still reduce the discovery to an abstraction. The universe is not defined by the objects it contains. It is defined by the vast, silent, lightless, featureless, expanding emptiness that keeps those objects apart. The objects are real. The objects are beautiful. The objects produced you, and everything you love, and every moment of consciousness you have ever experienced. But they are outnumbered, outscaled, outweighed by the nothing that surrounds them. The next time you look up at the night sky and see 1,000 stars burning against the darkness, remember this. You are not seeing the universe. You are seeing the exceptions, the rare, bright, beautiful, temporary exceptions, everything that your eyes cannot show you, everything between those points of light, everything that stretches from one lonely star to the next across trillions of miles of silent vacuum. That is the universe. That is what most of reality is made of. That is the truth that every photograph hides, and every number confirms. The cosmos is not a sky full of stars. It is an emptiness that contains them, and the emptiness is almost everything there is.